Right, so requested questions. Let's start off with this one. This is question 5B from review 5. Okay, we've got fractions and we want to solve for x. The first thing we want to do is make the same denominator. Now, if you notice, if I actually multiply these two together, I will in fact get that denominator. Okay, so would we agree if we focus on this part, right, we times the denominators together, so that becomes x times x plus 1. And then we have to cross multiply, because to make x become x times x plus 1, we times by x plus 1, so that becomes on the top line 2 x plus 1, right? And then we've got the minus, and we have to times this by x. Sorry for all the added bits and pieces. So that's minus 3x. And then this equals, on the other side, 7 over x plus 1. So we're really fortunate that it's got the same denominators. If it didn't, we would have to find a common denominator that all of these went into. So that, and that, you know. So imagine if that was, I don't know, x plus 2, and this was something else, we would have to times all of those together, which would be a bit of a nightmare. So lucky for us, it's a nice one. Now, because we've got these equaling, would you agree if I had x over 5 equals 4 over 5? Sorry, my gadget's playing up a little bit. That's 4 over 5. Wouldn't it mean that this has to equal this because they're the same denominators? So we've got the same situation going on here. It means that the numerators, so 2 x plus 1, take 3x, that will have to equal 7. And you can just go along and solve that like we normally would. Okay, I think you can take that away from there. Okay, this one's a little bit of a harder question, and I would argue that this fits better in simultaneous equations, which is down for the last topic that we were doing. Because if we look, we've got school has 200 students, and they're made up of boys and girls. So if we said the number of boys, let's call that B is the number of boys, and we'll say G is the number of girls. So therefore, because there's 200 students altogether, would you agree that the boys plus the number of girls has to equal 200? Okay, now because we've got the two unknowns, it's like your x and y. You know, if you preferred, you could have called that x plus y equals 200. All right, I'm just using B and G. Some of us get used to the whole x and y. So now we look at this: 1/3 of the boys have blue eyes. Okay, so we have 1/3 of the boys have blue eyes. And 1/4 of the girls also have blue eyes. Now, from what we did before with simultaneous equations, right, if I link this, we can say, well, that means we've got 1/3 of the boys, right, 1/3 of the number of the boys, plus 1/4 of the number of girls. And how many did they have altogether that had blue eyes? 57. Okay. But the problem that we knew from simultaneous equations, when we have two unknowns, we can't solve it. So we can rearrange this, I hope you agree, to say that girls, the number of girls, equals 200 minus the number of boys. And so what we can now do is substitute, right? We're going to substitute this for wherever G is here. So what we end up with now is now 1/3, so 1/3 times B, that's the same as saying B over 3, plus 1/4 of the girls. Now the girls is 200 take b, and 1/4 of that is the same as dividing by 4, right? And that equals 57. Now you can replace the b's with an x, and it becomes just a normal problem that we have to solve. So to get rid of the 3 and the 4, we're going to times through by 12. Okay, so if I times everything through by 12, what I'm going to end up with is, if I times this by 12, 3 goes into 12 4 times, so that becomes 4b. And if I times this by 12, right, the 4 and the 12 cancel to become 3, so that becomes 3 lots of 200 take b. And remember, if you didn't like the b, you can replace it with an x, and that has to equal 57 times 12. So this is a hard one. You know, I wouldn't worry too much if you didn't get it and, you know, you're not done. You would expand your brackets, then solve for b. Okay, hope that helps. The next one, draw number lines. So this was just, no, we'll go the other way actually. We've got a number line. So, you know, you've got 0, 1, 0, 1, 2, 3, and so on. Now, if I started with 5, then I'm putting it down here because x is any number and it's greater than 5. So it's going all the way along there, okay, beyond. However, at 5, because it is greater than or equal to, we use a closed dot to represent that, okay? If it was x is greater than 5, right, then we use an open dot to represent. That means it's right up to 5, so it can be 5.00001, but it can't actually be 5, whereas the closed dot means that it can be 5. Right, now 3 is greater than x. Notice the small point is pointing at the x, so the other way to write that, right, these mean the same thing. X is less than 3. So here's 3. X is less than, so it can be 2, it can be 1, it can be 0.1, it can be negative, whatever. So, but the not equal to, so it's a round dot and it's going that way. That's it. Hopefully with these, you remember, you treat inequalities, so these things here, you treat them exactly the same as an equal sign, except if you times or divide by a negative, then you change the direction of the sign. So good old algebra, to get rid of this 3, we're going to subtract 3, and what we do to one side, we're going to do to the other. So when we subtract 3 there, we're left with the minus 2x. That's greater than or equal to. Minus 4 take 3 is minus 7. Okay, now if that was just minus 2x equals minus 7, we would happily say, right, that's x equals minus 7 over minus 2. The negatives cancel out and we get x is 7 over 2, 3.5. But with what we've got here, we're saying, okay, because I am going to be dividing, right? I've divided here by negative 2, so my inequality here has to now go the other way. So it's x is less than 7 over 2, okay? If it was positive 2x, so if it was 2x is greater than minus 7 over 2, we would say, okay, to get rid of that times 2, we divide by 2. And so we haven't divided by negative, so we keep the inequality in the same direction, okay? So remember, if you multiply or divide by a negative, change inequality. So let's have a look at this one. To get rid of the divide by 2, we're going to times the other side. So we end up with 2x plus 3 equals minus 6. Get rid of the plus 3, we'll take 3. So minus 6 take 3 is minus 9. And then to get, and oops, look what I've done, naughty me. It has to be the inequality there. And I times by 2, so I don't have to change inequality. I subtracted 3, I don't have to change inequality. And now to get rid of this times 2, I'm going to divide by 2. So once again, I do not have to change the direction of the inequality. Okay? I'll leave that one for you because I think that's pretty much the same. You just expand your brackets and get your x's on one side. Again, only difference is if you multiply or divide by negative, change the inequality. Okay, all right, let's have a look at Roger. Roger was told to think of a number, so let's think and let's call that number x. We want to add 20, then divide the result by 3. So that means we're going to say x plus 20, and we're dividing, oops, that's my thing gone again. So we divided the result by 3. The answer was lower than Roger's original number. So remember, what was our original number? It was x. Okay, so it's lower than, so it's less than the original number, x. Okay, and you have to now find x. So get rid of the divide by 3 times, get x's on one side. You can do that. Right, so this time I got rid of the x here. Right, to get rid of that, I've subtracted it. So 3x take x gives me the minus 2. Sorry, minus 2 gives me the 2 over here. And to get rid of the times 2, we divided by 2. Notice the inequality hasn't changed. 20 divided by 2 is 10. Now please notice the wide part, right, the greater than sign, the wide part is here at the x, and it's still over there. So that's saying x is greater than 10. Okay, so those are the same. So hopefully that is good. I'll do the rest of your problems in the next video.